specific oxidation number for a given element in a given compound, and then how to apply the oxidation number rules in a compound. And we have been doing these all along in all these examples, but let us look at iron chloride. Okay, we have what?
Which iron chloride?
Well,
I want to do this one. This is my favorite iron chloride.
No, this one, FeCl3.
Do they both exist?
Oh yeah, yeah.
Okay, well how is that possible then?
Well, chlorine, we know, tends to have just one oxidation state when it's in a binary ionic compound, a compound made of just two elements. But iron's one of those transition metals. Remember all that D block stuff we did?
All the shenanigans with
Shenanigans
the 4s
and
and
stealing
3d and
the orbital overlap, and you lose the s electrons and then the d's or whatnot, and so
half-filled
on.
D's and
Right, or
craziness.
stable.
Right.
Okay, this is the result of all that stuff that
Right.
we made you learn back in the day. So we can have iron with two different oxidation states, and there could be more even. But in this iron chloride, FeCl2, if chlorine's -1, then what would iron be?
Well, then the chlorine would, the iron would have to be +2. First of all, we know that the chlorine has to be negative when it forms an ion.
Right.
So it's going to be negative. If it's negative, then the iron, being a metal and a wonderful electron loser, would definitely be positive. And using Mrs. Gregory's kind of intuitive algebra, we know that this is 2 times -1, which gives us a -2 charge.
Right.
And we only have one iron, then we know that whatever this number is, when added to -2, has to equal 0. So intuitively, we know that this has to be +2.
Right. So in that compound, iron has an oxidation state of +2. Hopefully, it's pretty obvious what iron would be in this compound. So if we have 3 chlorines and they're -1 because they're 1 away from the octet, they've taken that additional electron, -3 total on our anion side, still has to balance to 0. Well, what number -3 is 0? +3. Okay? And iron really can do this. There are many elements, especially the ones in the D block. We didn't get into that in our last couple chapters, but I hinted to some of you, and I'm sure you did too, Mr. Sustin, that there was more to it in the D block, and now we're really going to start to investigate that. So we base the oxidation state of the iron, the cation, on what we know about the chlorine and how many are attached. Okay? And let's do one other example. Applying the oxidation rules to a specific compound, just like we've been doing here. But let's do a base.
A base. My students had an interesting take on this one, but
Oh, okay.
we'll straighten them out.
Okay. You may remember that we demonstrated for you throwing chunks of sodium in water, well, placing them lovingly with a glass shield and so on.
With
water.
proper
We
safety,
saw
with proper safety.
proper safety procedures, but the guys in the video went into the pond. And sodium reacts with water.
We're at 12. Okay.
And will form sodium hydroxide. Okay? And now, what are the oxidation states of everything in this compound?
Well,
Let's look at what we know.
we've got metal
Yep.
and some nonmetals.
Right.
This is probably going to be an ionic compound. This is an ionic compound.
And we have elements in this one that have some rules. Now, the orders may be a little bit different. But if we look at our periodic table and we use our vast knowledge of the alkali metals, we know that sodium can only have a +1 oxidation state because it's going to lose its 1 valence electron. That's why it's so reactive. And we know we have rules for oxygen and hydrogen, but now they can't necessarily follow exactly the rule, or maybe they do. Let's see what happens. Oxygen tends to have an oxidation number of what? What's its most common oxidation number?
-2.
-2. It's got 6 valence electrons, 2 away from the octet.
That's correct.
And we know that hydrogen can either be +1 or -1, depending on what it's bonded with.
Yeah.
But what does it have to be here? If we have 1, minus 2 plus something that has to equal 0 at the end, then clearly hydrogen has to be plus 1,
Right.
like we would expect it to.
Right.
So in this kind of a compound where we have 3 elements, or maybe even more in some of them, we go with what we know from the rules, with things that are consistent, and we work our way back from there.
Right.
And
That's
that
it.
takes us to the end of the testing.
That's
So
it.
study up, people, for this quiz extravaganza.
It'll be there all weekend,
Mhm.
and Monday, I'd expect students to come in with a couple of questions.
Yeah, ask some questions and be ready to go and kind of wrap up what we're doing here in this chapter.
Yeah.
Happy studying.